This is one of a series of good answers presentations, offering evidence to answer skeptical challenges to the Bible's accuracy. That evidence can take several forms. It may be simply a knowledge of history, or an archaeological discovery, or a better understanding of anatomy and physiology, or of the wonders of nature. It may come from astronomy, geology, or anthropology. Today, I would like to share with you an outstanding discovery from the world of genetics, one that bears directly on how we view the book of Genesis and on the history of the human family. The source of this talk is a new book by Dr. Nathaniel Jeanson, a Harvard-trained specialist in developmental biology. The book is called Traced: Human DNA's Big Surprise. The research and conclusions found in it are stunning, and I will do my best to convey their essence to you clearly and accurately. But you'll be best served and most rewarded to obtain a copy of his book for your own study. Just released in 2022, it is already in its third printing. Most of us were exposed to a smattering of biology, or even genetics, somewhere in school. But it's a field that is developing so rapidly that what we were taught may not be an adequate background to understand Dr. Jeanson's work. Let's come at it from a bit more familiar direction. Well, most of us know a bit about family trees or genealogy. We may at one time have tried digging into our own family history. I must confess that it's been a hobby of mine for a number of years. One can certainly learn some surprising things from the pursuit. They say that Mark Twain was once asked whether he had studied his family history. He replied that he had climbed around in his family tree for a while until he found a couple of hanging nooses, and then he quit. Enough said, I suppose. Well, what might we learn from genealogy? Most of us would want to know who our own ancestors were, and whether they may have been important. But if we pursue the question more broadly, we will enter the territory Dr. Jeanson explored. Are all peoples related? How long, for that matter, have humans been around? And those of us who are Christians will have questions of our own. Is the variety of human languages really a result of a crisis at the Tower of Babel? And was there really a person the Bible calls Noah? Could he be our ancestor? Well, if you have ever dipped into genealogy, you know the sources you have to explore. Most of us start with the informal ones, the personal memories of our elders and records, such as diaries they may have kept. Photo albums are a rich source, and perhaps even the records entered in a family Bible. But that's only a start. Legal records are essential. Census documents, immigration records, birth records, plus school, military, criminal, marriage, death, and cemetery records. Up until just a few years ago, that was pretty much the limit. But recently, knowledge of genetics and of our DNA has opened a third source. That is where we look now. But which way? We've all seen diagrams of family trees much like this. It allows one researcher to do a personal trace, his or her parents, grandparents, greats, and so on, ever expanding. That's what the DNA tracing companies do for us. They offer to trace your individual family history. But have you noticed that the metaphor of the tree seen this way is backward? That is, trees grow from the root up. This diagram portrays the researcher as the trunk and his ancestors as branches and twigs. But they came first, didn't they? Well, upside down or not, that's an individual's family history. What's important is that there's another way to trace our history. That is to work backward from a lot of people, tracing each one's father, then his father, and on back, to see if those different people were related back there somewhere. Whoa, did I say his father? That's right. This approach traces the Y chromosome, which is the one that determines a male child. Its advantage is that we get access to history that can go all the way back. Traditional DNA tracing can't do that. It peters out after several generations. To make sense of what follows, we'll have to go back to school for a few minutes here. You've heard the term 23andMe. They provide DNA tracing for interested folks. The 23 there is the 23 pairs of chromosomes that each normal human has. One of those pairs determines the person's sex. If that pair consists of 2 X chromosomes, the bearer is female. If the pair is of 1 X and 1 Y, the bearer is male. Notice that a Y chromosome only exists in a male. When fertilization takes place and the DNA of the father and mother join, each one's chromosomal pairs split apart, with half of each pair joining to form the new person. The father has an XY pair, and the mother an XX pair. When the pairs split to form a new pair, it may happen that the X chromosome from each parent is used, and then the resulting child will be female. Only if it is the Y chromosome from the father that contributes to the new pair, that the child will be male. We are fearfully and wonderfully made, aren't we? But there is more to this chromosomal ballet. Note that the Y chromosome is passed only from father to son, or rather, it's an exact copy of that chromosome, delivered unchanged. Well, not quite unchanged. We now know that despite error control mechanisms designed into the process, very minor errors occur in the copying. These do not affect the overall function of the chromosome. Think of the process as like another male-related possession, a car. A man has saved enough to buy a car he will love. He drives it for years, maintaining it carefully, and then passes it on to his son. Same car. Well, there are a couple of scrapes on the underside of the frame, but the car is still functional. And if there's strong father-son tradition, that same car may go down to the grandson. A few scratches may have been added, but it's still a great car, and the same one granddad enjoyed. That's our Y chromosome, handed down from father to son, generation after generation. And like that much-loved car, with the dents and scratches it has acquired over the years, the Y chromosome's accumulated minor errors can reveal more than we might ever have guessed. One thing it can do for us is to identify people groups. Here's a rather oversimplified example. Suppose we are studying Y chromosomes in some Native Americans. All of them will have some errors that we can see under an electron microscope. But notice this first group. They have the exact same set of errors. That suggests that they were all descended from the same parent, or grandparent, or whatever. Who are they? All of them belong to the Sioux Nation, and the errors in their Y chromosome confirm that relationship. Now look at this next group. They too have the same pattern of errors. And who are they? They'll be proud to tell you. We are all Navajo. And the third group? Apache. The Y chromosome can be used then to identify people groups. But there is even more to be seen here. Compare all three of these groups. All of them share one specific error right here. What does that tell us? That the groups are all related, even farther back. All are what we call Native American. You may be one step ahead of me here, and realizing that there is a Y chromosome trail back into history. With each generation, copying yields a few errors, and we moderns have inherited the accumulated errors of all those generations before us. But now, let's go back in time. With a few errors in each generation, then the preceding generation would have slightly fewer than we do. Just a bit farther back, we will find fewer of them. Farther, the number of errors will be even less. If we kept going back with fewer errors in each generation, eventually we would come to a chromosome with no errors, a perfect genome. Christians would call that male ancestor Adam. He was, after all, created perfect. Now this is basic genetics, something we might find in most any textbook, minus any mention of Adam, of course. But when Dr. Jeanson studied it, he saw a rich potential to extend human knowledge. Who's he? Well, he has a Bachelor of Science in Molecular Biology and Bioinformatics from the University of Wisconsin, Parkside, 2003. And his PhD is in Cell and Developmental Biology from Harvard Graduate School of Arts and Sciences, 2009. The Germans would probably call this young scientist a Wunderkind. He already has produced 3 major books and many scientific articles. And the book we'll reference here is Traced, Human DNA's Big Surprise, out just this year, 2022. Jeanson saw that some scientists were trying to determine if the Y chromosome could be a clock. It was known that in each generation a few errors were introduced, but on average, how many errors per generation? There had been 2 early studies done from 2009. As Dr. Jeanson tells us, quote, 2 Chinese men of a known genealogical relationship going back to the 1800s had their Y chromosome DNA sequences determined. The resultant rate of copying errors was slow. It fit the existence of a Y chromosome atom, the ancestor of all living men, about 200,000 years ago. In 2015, a study of hundreds of Icelandic men produced the same result. That's from Jeanson Traced, pages 56 and 57. So, a very slow error rate, which would mean that human history goes back hundreds of thousands of years. But Dr. Jeanson notes that these studies were limited in both their funding and in the sophistication of the tools that were available to them. Then there were two more studies, 2015 and 2017. In these studies, the number of father-son Y-chromosome differences was approximately 10-fold higher than the expected number. That's a quote from the report. And then Jeanson goes on, the 2017 Y-chromosome copying error rate again implied that Y-chromosome atom existed about 4,500 years ago, end quote. 10-fold higher. That should have sent shock waves throughout the scientific community. But it didn't. The reason, Jeanson points out, is that the researchers muted that finding. In one study, the result was adjusted to meet the researchers' expectations. In the other, the error rate was, oddly enough, not expressly stated, but it was present in the data and easy enough to extract. So, two studies, done with the best methods we have, give us an error rate for the Y chromosome that permits the human race a history of just about 4,500 years since Noah. But why Noah rather than Adam? Because human history has a bottleneck called the flood. Only 8 persons survived that event, 4 being males, and 3 of the males were sons of the 4th. So, the trace goes back as far as that one individual, Noah. Let's see where we are now, because the story isn't over. It's clear that the Y chromosome is a very powerful tool. It can help, as we saw, to identify people groups. And, pursued farther back, it can show us where those came from. And with further study, we can learn when those people groups arose. That has been the chief thrust of Dr. Jeanson's book. It should help to take a few minutes to see how he accomplished what he did. He began, of course, with people, 600 individuals from different ethnic groups, from scattered locations all around the globe. Here they are, each one an almost microscopic mark on this sheet. He obtained personal information and personal histories from them. This, along with their apparent ethnic heritage, allowed him to assign them provisionally to the genetic categories researchers use. Then he took a close look at their Y chromosome information. That probably caused him to reassign some of the genetic labels that we see. All of this was directed toward deriving a set of maps, charts, and photos that would provide the basis for a family tree to determine if and how they all related to one another. That was the goal. But the chart you see here, and the over 200 others, were not coming quite yet. You see, there was a lot more to the process than that. Y chromosome tracing itself is a difficult business because of the mixing of peoples over time. Migrations occur. Plagues wipe out vast numbers. Wars, treaties, and social unrest all affect who meets whom and who might marry. And any careful researcher will supplement his genetic study with all other relevant clues. Linguistic history helps. That is, there are families of languages, English and German belong to the Germanic family. The similarities between these languages show that these people groups were once associated in some way. We can all see the similarities. Brother, Bruder. Father, Vater. Speak, sprechen. See, sia, and so on. French, Spanish, Italian, and others are in the Romance language family. These linguistic relationships help to clarify the picture, and that information goes into the mix. Then there is political history. What we know of the historic movements of peoples, migrations, wars, and the like can tell us a lot. For example, the 8th century Muslim conquest of North Africa explains why there is a substantial Near Eastern genetic signature in Egyptian and North African peoples. Some of the Arabs obviously mixed with the native population. Dr. Jeanson also saw the value of tribal legends and traditions to provide clues for where various people groups lived or moved in the past. I was surprised to see that the Lenape Indians of my home state of Delaware have traditions that record how their ancestors crossed the Bering Strait from Siberia into North America. Assembling all these clues and others produced some amazing results. Dr. Jeanson's book, chapter by chapter, shows us the history and movements of the people groups in Egypt and Africa, Europe and Central Asia, the Middle East, South Asia, the Far East, the Pacific, and the Americas. His findings confirm, in some cases, what our history books tell us, and in other cases, they show that our history needs to be corrected. Once we've read through these chapters, we find some major conclusions. First, all humans came from one person about 2500 BC. Jeanson says, the 2017 Y-chromosome copying error rate again implied that Y-chromosome Adam existed about 4,500 years ago. Page 57. By using that term, he doesn't mean biblical Adam. He's not speaking in a biblical framework at this point at all. He's just saying, as we saw, that tracing back generation by generation with a known error rate per generation, there will be fewer errors the farther back we go, and we reach a minimum point around 2500 BC with one male ancestor from whom all humans are sprung. Those of us who know the Bible will immediately think Noah. When he entered the ark, he was the oldest human male and the father of the other three. That leads to a second major conclusion. 3 major groups arose from this one ancestor. Jeanson states this in the captions of several of the some 200 colored charts in his book. Here's one caption: 3 fundamental partitions in the Y-chromosome tree. This image represents a zoomed-in version of the deepest parts of the tree. Caption to color plate 209. Once again, those of us familiar with Scripture will be thinking, Shem, Ham, and Japheth. The Bible makes it clear that all males born after the flood are descended from these 3. And the third major assertion embodies these first 2. The Y-chromosome tree eventually narrows to a single bottleneck, a single person around that date. Or, as Jeanson puts it, recall from chapter 6 that we put the beginning of the Y-chromosome tree about 4,500 years ago. page 284. It's important to keep in mind that Dr. Jeanson did not derive these conclusions from the Bible. They are the direct result of his tracing the Y chromosome back from many of the people groups in our world. But now we can put Bible and science together, can't we? Let's do that. Jeanson's research into the Y chromosome tree shows how the world's people groups are all related to one another. He says, previous chapters in this book have already associated major Y chromosome haplogroups, that is, genetically related people groups, to these far-flung regions, and we did so independent of these biblical observations. Page 288. Did you catch that? He did not start with the Bible. He followed where the pure science led, and it led to just what the Bible asserts. But it gets better, because there is more here than Noah, Shem, Ham, and Japheth. Science has pointed us to them, and that's a lot. But the Y chromosome tree has more to say. Remember the so-called Table of Nations in the 10th and 11th chapters of Genesis? They tell us which nations are descended from those survivors of the flood, and they give us, person by person, the line from Shem to Abraham. Well, Jeanson's work reveals that the Y chromosome tree, when overlaid on that Table of Nations, matches it, point by point, in the number of generations and in their branching patterns. Here's what our author says. We've just observed a tight and detailed correlation between the biblical genealogical record of Shem and the Y chromosome tree, color plate 218. We also observed correlations between the biblical expectations for Ham and Japheth in the Y chromosome tree, color plates 207 to 215. That's on page 292. Let's see those three groups from one of Dr. Jeanson's many charts. Here we find Shem. This part of the tree is outlined in blue and contains, as you see, the Americas, the Pacific, Siberia, parts of Asia, and, of course, the Jews. Japheth's branch, outlined in green, includes Europe and much of the Middle East. And then Ham's branch, highlighted in pink, gives rise to much of Asia, Africa, and some of the Pacific Islanders. By the way, as you can see, there is quite a bit more on this one chart. But for that, you'll have to read the book. Let's just move on. But before leaving this study, we must look closely at one of the meeting points of the Bible and science. Evolutionary scientists tell us that humans evolved from ape-like creatures around 200,000 years ago, while the Bible indicates only a few thousand years elapsed since creation of humans by God. This is a crucial point of controversy, and we're often told that we must choose between science's answer and the Bible's answer. But we don't. Jeanson's genetic research, solid science, points to an answer here, and it is the same as the Bible's. Let's see why. Take two widely separated people, say Joe Jones in the USA and Chang Li in China. Each has a Y chromosome riddled with tiny errors. 440 in Joe's chromosome that are different from Chang's. How far back do we have to go, with fewer differences in their error patterns in each generation, to find a single ancestor for both of them? Well, the Bible says about 4,500 years to Noah. Scholars have calculated this ever since Bishop Ussher. The Bible gives us detail like this in Genesis 11. Quote, when Shem was 100 years old, he fathered Arphaxad 2 years after the flood. When Arphaxad had lived 35 years, he fathered Shelah. It's Genesis 11, 10 to 12. Noting the ages of these patriarchs when they became fathers, and projecting an average down to today, we get a working number of about 30 years per generation. Dividing that into 4,500 years, we find about 150 generations from Noah to now. All right then, if our two fellas have 440 different errors in their Y chromosomes, and it's taken 150 generations to accumulate those differences, what is the average error rate? That's right, 3 errors per generation. That is what the Bible would predict if its history were accurate, to explain the observed differences in the errors of those two Y chromosomes. Now, you ready for this? What have the best studies of the error rate in the Y chromosome copying process shown generation by generation? Yep, 3 errors per generation. An exact correspondence with what the Bible would predict. And so, here's the bottom line. The human race has one family tree, not several. It has 3 major groups, descended from Noah's sons about 4,500 years ago. And, projecting the pattern back beyond Noah, humans have been around for only about 6,000 years. The Bible says so. And thanks to the groundbreaking research of Dr. Nathaniel Jeanson, we can say that the science of the Y chromosome agrees. Why not? After all, who made that little entity? If you have questions about this lecture, or any of the others in the Good Answers series, you may address them to me, Dr. Jerry C. 4 at yahoo.com.